Okay, so now we are going to focus on evaluating definite integrals. And we are going to be considering here the integral from 0 to 6 of the function 4 minus 2x dx. Okay, and first we're going to evaluate this using the concept of net area. So I've set up some graphing axes here so we can graph our function. Okay. And our function is f of x equals 4 minus 2x. Or if you prefer to look at that as negative 2x plus 4, sometimes people like that because then you can see that it is a line and you can see the slope and the intercept really clearly. The intercept is going to be at 4, y-intercept up here. And then our slope is going to be negative 2. Okay, so we'd have a line going through these points that I just put, something like this. Okay. So there's our function. And now we want to integrate that from 0 to 6. Okay, so 0 would be right on the axis here, and then to 6. Okay. So we can see that there's going to be some area that is above the x-axis, and then there's going to be some area that's below the x-axis. So we are going to need to focus on this idea of net area. And remember from earlier on in this section, the idea of net area was just above the x-axis, the area counts as positive. And then if the area is below the x-axis, it counts as negative. Okay, so let's start with getting our positive area. That would be this little portion right here. Okay, so above the x-axis. All right, that little triangle's area would be, I'm going to label this like a sub plus. That way I remember that this is counting as positive area. And that's a triangle 1/2 base times height. And the base there we can see is 2 units wide. And the height of that triangle is 4 units. So 1/2 times 2 times 4, and that would give us 4 units of positive area. And then below our x-axis, there's a couple different ways to think about this, but the area that we're looking at is right in here. Okay. And so I'm going to label this as a sub minus. That way I remember to count this as negative. And it's a triangle as well, 1/2 base times height. The base here, just looking at it in dimensions, it is 4 units. And the height, I'm going to just consider this a distance of 8 units. Now, some people like to put -8 on that. That also reinforces the fact that this value is going to be negative. So you can look at it either way, whichever way makes more sense to you. If you want to call this 8 units of distance, or if you want to call this -8 units, because that's literally the value on that point. Either way will turn out fine as long as you remember that this area is going to be negative. So that's 16 units of area, but I'm going to need to count that as negative. Okay, so -16 units. And then we're getting +4 units right here. So the net area is going to be 4 units plus that negative 16 units. And so we're going to get negative 12 units of net area. I guess these would be units squared, I suppose. Units squared, since we are talking about area. It gets a little funky to think about it that way. The units are a little weird, but with the integral, we're not quite as concerned with the units on our area as we are with the value, because what this tells us is that the integral from 0 to 6 of 4 minus 2x dx, that integral is going to equal negative 12. Okay, and so that is the value of this integral. Okay. Now, in the next video, we're going to do this integral using the Riemann sum definition. We're going to set up the Riemann sum and evaluate it. But when we do, we should end up with this same answer at the end. It should be negative 12, whether we're using the net area method or the Riemann sum method. So we'll check that out in the next video.